So today we're going to show you how to take the information we took on the unit circle from yesterday and then use it to graph the trig functions of sine and cosine. Okay, so here we go. So this is what a coordinate plane would look like for a sine and cosine graph. Now generally when you have sine and cosine on the x-axis, right, those would be the radians that are on the inside of the unit circle. Okay, so you can see at the beginning on the left side we have 0, okay, and we go all the way to 2 pi, so it's once around the unit circle. And these are all the radians that are listed inside the unit circles, from pi over 6, pi over 4, all the way to pi, and then 7 pi over 6. All these are in the unit circle that you did yesterday. Okay, you can also see on the y-axis, you have all the values that were in the points on the outside of the unit circle. You got 1/2, root 2 over 2, root 3 over 2, and 1. And then on the bottom, all the negative values as well. Okay, so now if you remember from yesterday, we talked about sine being y and cosine being x values. So to graph these functions, you're going to use those values all around the unit circle, x and y, for sine and cosine. And the x values are going to be the radians on the inside of the unit circle, and then the y values in your graph are going to be either the x terms in the points around the unit circle, or if you're doing sine, it's going to be the y terms in the points on the unit circle. So let's show you how that works. Okay, if we're doing a cosine graph, okay, if you started at 0 radians, on the unit circle, 0 radians is the x term at 0 radians is 1. All right. If you looked at pi over 6, the x term at pi over 6 is root 3 over 2. At pi over 4, the x term is root 2 over 2. And we keep going around the unit circle. Pi over 3 for the x value on the point would be 1/2. And we keep going around the unit circle as we get all these points. Okay, and if we graph all the radians around the unit circle, your graph would look like this. Now, the issue with this graph, and this is the way a cosine graph will look across 2 pi, one rotation around the unit circle, using all the x values in the points. Okay, so this is what the cosine graph would look like. The issue you have, as I was saying, was this is a lot of points. There's no way that we want to use anything. There's like 16 points in this to graph a cosine graph. Okay, I'm going to get to that in a minute. Okay, if you want to do a sine graph, you do the same thing, but for sine, you're using the y values of the points on the radians. Okay, so at 0 radians, the y value at 0 radians is 0. So we put a point at 0. At pi over 6, the y value of pi over 6 on the point is 1/2. At pi over 4, it's root 2 over 2. Pi over 3, it's root 3 over 2, and so on and so forth. And what happens is you start to go up and down using all these values from the unit circle, the radians, and then the y values of the points in the unit circle to graph the sine function. This is what a sine function looks like. It goes swooping curves up and down through all these points. But again, there's a lot of points. Okay. Now, one thing we do want to like to show you is that is one period. So from 0 to 2 pi, so 0 to 2 pi is one period of the sine graph. If we kept going around the unit circle, you can see as we go around the unit circle, the graph keeps going. You get to 2 pi. If we kept going again around the unit circle some more, this graph would just repeat itself. Okay, so it was 2 times around the unit circle. That's 4 pi. And as you can see in the small little font up there on the x-axis, the end of the graph is 4 pi because it's went around the unit circle twice. Okay, so that's why this is called a periodic function. It just keeps repeating the same motion over and over and over again. All right. So here's turning the impractical number of points into a practical number. Okay, if you're doing cosine or sine and sine, okay, you're only going to use 5 points. Okay, and those are the 5 points at the axes, the x and y axis of the unit circle. So cosine at 0 pi is 1. Cosine, so the x term at pi over 2 is 0. Cosine, the x term at pi is -1. At 3 pi over 2, the x term is 0 again. And at 2 pi, again, it's 1. So we're going to use these 5 points to graph our cosine function rather than the 16 points. Okay, and again, this is what the graph should look like. Okay, notice there are curves in this graph. Okay, please do not graph it. Oh, hold on. Sorry, I jumped a little bit ahead of this. Why does cosine start at 1? Because on the unit circle, 0 pi The x term is 1. That's why it starts at 1. Okay, please don't graph your cosine graph like this. It is not a V. It has gentle sweeping curves, not pointy parts. All right, now let's look at sine. Sine, you're going to do the same thing. You're going to use the same 5 points. You're just going to have different values because it's y values instead of the x terms. So at 0 pi, the sine values, which would be the y terms of the points, is 0. Okay, at pi over 2, the y value is 1. At pi, the y value is 0 again. At 3 pi over 2, the y value is negative 1. And at 2 pi, the y value is 0. So you have a gentle sweeping curve of the cosine function that looks like this. All right. Now, why does sine start at 0? Because on the unit circle, 0 pi, the y value is 0. Okay. All right. Now, again, how not to graph a sine function. It is not a pointy thing. This is not what you do. It's not a pointy mountains and valleys. It is a gentle sweeping curve like you saw before. All right. And that's the basic introduction of the sine function and the cosine function. So now you can graph a basic sine and cosine graph. All right. That's it.